Okay, welcome friends. Let's do a little bit of 3E exponential equations. So I'm in our book. So think about an exponential equation, an equation with exponents in it. The example it starts off with, let's look at it right now. 2 to the xth power equals 8. Now that one you could figure out probably pretty quickly. You know, well, what do you raise 2 to get to 8 would be 2 to the third power. But that's just using kind of our intuition almost, and we're not really, how are we doing that? So let's get a methodology of how we can do this. So all these problems are going to basically come down to this method. And if you read the part in the book, it's telling you there are several ways, approaches to solve this problem. What we're going to do in this section is we're going to use the same approach every time, which is kind of nice. And of course, what will happen is they'll make us get a little bit clever as we go. So the technique is basically to create a common base. So in this case, 2 is already at the most common base. 8, though, at the most lowest base, I guess. You can't really break 2 down. But 8 could be broken down. That could be 2 to the third power. And now we have a common base. They're both in the power of 2. And so if you think about that just for a minute, 2 raised to the xth power is the same as 2 to the third power. So what does x have to be? Well, x has to be equal to 3, right? Because 2 to the third power is 2 to the third power. So basically what we're telling us is if we can break it down, like here's the generic form of that. If you can break exponential equation down to this form, a to the x equals a to the k. So it can be x and k can be anything. Then once you get to this point, you can just get rid of the exponent part. You can get rid of the base, and you can say x must be equal to k. In other words, the left-hand side must be equal to the right-hand side if it's in that format. So that's the key. So let's do a few problems and you get the hang of it. So I'm going to start right with, how about we jump into 3E, exercise number 1. 1A, that's the easy one. Let's jump to 1C. 3 to the xth power equals 81. So right now I already have the 3. I'm going to break 81 down to 3 times 3 is 9, times 3 is 27, times 3 is 81. It's 3 to the fourth power. That's a piece of cake. So x must be equal to 4. That's not a big deal. So let's go to a slightly harder one. How about we go to F? Or we can go to E. 3 to the xth power is equal to 1/3. Well, 1/3, you should remember, is equal to 3 to the negative 1 power. And now you know that x is equal to negative 1. So not too bad. What about, now let's get to the ones that get a little trickier. Let's go to, like, H. 4 to the x plus 1 power is equal to 64. Okay, so now the common base, we could go to 2, but maybe, can you go to 4 times 4 is 16, times 4 is 64. You could also you could stay in base 4, because 4 to the third power. So you really could have you could have stayed at 4, or you could have probably gone down to 2. But now you have the same base on both sides. So what happens is this whole thing, x plus 1, must be the same as 3. Just think about that, if that's a little bit confusing. X plus 1 must be the same as 3. Because 4 raised to that x plus 1, whatever that is, has to be the same as 4 raised to the third power. So x plus 1 has to be 3. Well, their x has to be 2. 2 plus 1 is 3. Not so bad. So that's kind of that's the general trick there. Those are the easy ones. Want to try another harder one? No, that's enough for this intro video. I'll make a second one with harder ones.